Whenever you clean anything, there are three general techniques. So you have mud on your new car. You can take a dry wiper and try to dry the mud off. You can take a hose and try to spray it off, or you can go professionally to a car wash. Well, precision cleaning a fiber optic end face is just like a very, very high-end car wash. In addition to the three general techniques, there are three tenets. Once again, we think of them almost automatically when we're cleaning anything. What's the debris? Where's it located? And what's the best means to remove it? For fiber optics, this debris is very small, and where it is located, we're going to understand goes beyond the traditional field of view. And then the best means to remove it, well, it's the adaptation of wet to dry cleaning.
What do we mean when we say field of view? This is the field of view. An east to west axis, a north to south axis, and this on a 400x scope. Notice we can scroll. This particular instrument has what's called a scroller, so we can scroll out to the edge of the horizontal surface. Left to right to the edge of the horizontal surface. And why is that important? Because if there is contamination out here on the edge, it's conceivable that it can move into these active zones, this zone 1, 2, and 3.
After more than 20 years of study and development and patent of a new way to view the end face, I'm adding a zone 4 and a zone 5 to the connector. Also need to include adapters and alignment sleeves. The dust you see is on what I term a zone 5 intersurface. So connector surfaces are now recharacterized into primary, as defined by IEC, and then secondary, as defined by the new inspection devices leading to this new research data. The history of fiber optic cleaning is really pretty interesting. For the most part, this is product-based and began 98, 99 with the introduction of the clay top reel cleaner. At that time, there was dry cleaning and wet cleaning. These slides talk about dry cleaning, wet to dry cleaning, and then introduce an adaptation. The problem with dry cleaning is that it can induce debris by static field contamination. Dr. Tatiana Berdenskaya in the mid-2000s did a lot of work of this at Celestica and still is involved. There's another issue, and that's that dry cleaning moves debris around, creates streaks. Take a look at that complex debris there to the right. That's dry cleaning on a dry wiper, and all we're doing is moving the high points of the debris around. So what is wet cleaning and wet to dry cleaning?
Let's review wet to dry cleaning. This is a fingerprint, and I'm going to clean it using an isopropyl alcohol wiper. These are commonly marketed as fiber optic end face cleaners. And all I'm doing is drawing the end face through the wiper. As you look at this, well, you begin to see this needs dried. So let's dry it. This appears to be clean and dry. Let's look outside of the field of view. And what you see is this is excess solvent that's being fed from zone 5. The trouble is that this image passes the IEC standard. This image passes automatic inspection. But out here, in the time of post-cleaning and inspection, solvent is being fed. So all of this says is it's very important that you choose your cleaning process carefully, and also very important to select one of the new generation of fiber optic grade cleaners. These are intended to be used in minimal amounts, far less than was used to clean and flood this end face. So what is wet to dry cleaning? I call it solvent transfer. Isn't solvent transfer wet to dry? Well, no, it is not. We coined the term wet to dry 2004-2005, part of a training program for all of the major RBOCs and MSO. So solvent transfer is simply this: small amount of solvent. I prefer the precision hydrocarbon simply because its solvency works on the widest range of debris. Chemtronics called that combination cleaning because they tested it against some pretty rugged combination debris. But we'll talk about that later. When we're using a probe, what we want to do is we push it down just enough so that the thread touches the solvent. If we push down, we'll move it past so it won't be moistened. But what we will do is we'll do it twice. Once to clean, once to dry. Same thing if we're using a swab. I count 1, 2, 3, 4, 5. And yes, this probably means you're going to use 2 swabs, but it also means that you're going to end up with a very high level of first-time cleaning. What we don't want to do is we don't want to overly saturate the swab like this. That's too much solvent. If we're using a reel cleaner, one of the downsides with the reel cleaner is, of course, it has a smaller cleaning surface. So your drying area isn't as good. It works, it can work, just be aware of it. The cleaning platforms were designed with a broad cleaning surface so that you would get multiple cleanings, multiple drying, and it would go wet to dry. Yeah, there you go. That's where the wet to dry comes from.
Digital color photography is not intended to replace existing fiber optic inspection. It's intended to augment it, give other perspectives. The yellow bars define new areas. These are called intersurfaces, spaces between fibers, spaces with contamination that can cross-contaminate. There are sophisticated connectors such as the SMPTE LIMO 401 to the right there. That's fiber, power, data. One of the more remarkable images here is the APC-SC. Notice you can see that the fluid has depth, and that debris is just about at the IEC definition of the horizontal end face. The rest of the images show debris in other sections. Take a look at the adapter. The fiber is clean, but the alignment sleeve itself is contaminated. Cross-contamination from intersurfaces, horizontal, vertical surfaces. So take a look at fiberopticprecisioncleaning.com. Subscribe, please. Like if you do. Certainly comment if you have questions or concerns. Thanks for your time. Thanks for your consideration. Let's do this right the first time.